section, 3.5, box plots for displaying summaries. We're going to be looking at how we can graphically display some of the summary statistics we've been talking about in this chapter. The following data set contains the ages for the players on the 2015 New England Patriots. So we have a frequency table below, and we are going to look at what this means and how we can figure out some of our summary statistics. So if you can see along here, in this row, we're given different ages, like 22 years old, 23 years old, all the way up to 38 years old. And the row below it are counts. This means that 8 players were 22 years old, 10 players were 23 years old, 8 players were 4 years old, and all the way up to 1 player being 38 years old. So data like this is very common to see, and you have to be careful when you are calculating things that you're keeping track of what the actual data is and what are your counts. So let's answer the following questions. What do you suspect the shape of this distribution is, and explain? So one way to do that would be to kind of graph it out a little bit. So I have 8 players that are 22 years old. So it's kind of like you could make a sketch of a histogram. Next, I have 10 players, so a little bit taller bar, that are 23, 8 that are 24, 18 that are 25, 10 that are 26, 7 that are 27, 3, 6 that are 29, 3, as I said, this is a sketch, and 1. So this gives you kind of a general look, very, very sketch of the histogram, but it looks like we're dealing with some skewed data. Find the mean age. And although we wouldn't probably use the mean as our summary statistic of center for this, since we just said it was skewed, it's still important to know how to find the mean in a chart like this. So when we calculate the mean, what we need to do is add up all of the ages of all the players. And so if we add up all the counts, it turns out that we have 80 players we're looking at. So in our denominator, we're going to have an 80. And the numerator, which I'm not going to write all out for us, but would look like this. We'd either have to add up 8 times 22 player. Let me try that again. 8 players who have age 22, or we could write that as 8 times 22. Then we have 10 players who have the age 23, 8 players with an age of 24, and we keep going on until we get up to the 1 player with the age of 38. If we do all of that, we find out that our mean age is, 25.9. The median age, to find the median age, we probably want to use our formula for finding the position of the median, which was n plus 1 over 2. So we're looking at 81 divided by 2, which is 40.5. Now we can count in from the beginning to find our 40.5. So we're going to take the average between the 40th and the 41st data point. So starting over here, we're going along, we have 8 plus 10 is 18, plus 8 is 26, plus 18 is 42. And so at this point, we've already passed the 40th and the 41st, which tells us that the median age is actually right in that bin. It's 25. So the median is equal to 25. Next, we want to find the first quartile. The first quartile is going to be the median of our lower half of our data set. And so that's going to be from 1 to 40. And so we're going to find our first quartile at position 20.5. In other words, we're going to average the 20th and the 21st data point. So again, and I'll write in red here, we're going to start over here and go over till we get to the 21st data point. So 8 plus 10 is 18, plus 8 gives me 26. And so now again, we've passed the 20th and 21st right in this bin. And so our Q1 will equal 24. Q1 equals 24. We're going to do the same idea to find the third quartile. We can count in from the other end, from the back end. So we need to go in 20 data points starting over here. So again, I'm adding up the counts to see what age I'll fall in. So here, 4, 7, 10, 16, 19, plus 7 is 26. And so the third quartile falls in this bin, meaning that our Q3 is equal to 27. Now our minimum age, we're going to be able to read that right off of our table. That's 22. And our maximum age is 38. Our range will be our max minus our min, which is 38. Oops, we're at 28. 38 minus 22, which is equal to 16. And our IQR is equal to our Q3 minus our Q1, which we calculated. Q3 was 27 minus 24, which equals 3. So the five of these summary statistics make up a summary called the 5-number summary, and it's often shorthand written FNS. The 5-number summary is specifically the min, Q1, Q2, Q3, and the max. So our min is 22, Q1, 24, Q2 was 25, Q3 was 27, and our max was 38. So together, these 5 data points make up our 5-number summary. The dot plot below shows the location of the quartiles Q1, Q2, and Q3 for the price of a gallon of regular gas at 12 gas stations in Austin. This graph can be found in your textbooks on page 111. So that shows you your Q1, your Q2, and your Q3. But most often the way we display this information is in a graph called the box plot. A box plot is a graphical summary that provides a visual display of your 5-number summary. So you can find out all of your information by looking at a box plot for the 5-number summary. The box plot below shows the quartiles for these gas prices. So what a box plot looks like is it has this box or rectangle here, okay? And each end of this is your Q1. And this end here is your Q3. The middle line, the division line right here, is representing your Q2, which we also know is your median. And then it has these extensions on your box, which are called whiskers, and they extend out to your minimum and to your maximum. And so this is a very useful visual summary of your 5-number summary because this box here in the center really is also your IQR, the Q3 minus Q1. So you can see the spread of that middle 50% easily when you're looking at the box plot. Does the box plot give us as much information as the dot plot? Not necessarily, because we don't have actual data points. It's a summary. No actual. But it is very useful because it helps us see the spread of the data visually by seeing the box. And it's nice when you're comparing between two groups. So let's draw a box plot for the distribution of age for the New England Patriots, which is the data set that we saw on the first page of today's notes. To be helpful, I'm just going to copy over the 5-number summary so that we can use that to draw our box plot. So remember that the actual rectangle goes from Q1 to Q3. In our case, that's 24 to 27. So I like to draw that rectangle on to start with. Next, I'm going to place my Q2 or my median at 25. And then I need to draw a whisker out to 22 and a whisker out to 38, my max. So this is what a box plot for that data set would look like. Compare the box plot to the following dot plot and comment on any differences and similarities. So here is a dot plot of the same information, and again you can see that you can't tell exactly what's going on because in the box plot because we don't have the actual data points the way we do here. And one thing we notice is that you really lose the fact that this data point is so far away from the distribution that it's probably an outlier. Up here, we can't tell where the next closest data point is to 38. So that gets kind of lost in this dot plot that we were just drawing. So yes, the dot plot, the dot plot suggests that doesn't suggest that there's an outlier. We can't tell for sure. Okay, let's try this again. The dot plot suggests, yes, that there's an outlier. The box plot does not tell, you cannot tell for sure whether or not we have an outlier. So there are some ways to determine whether there's an outlier, and then there is a way that we can display this in a box plot. So this, there is an outlier test that we use with our IQR to determine some cutoff points for outliers. And so what we do is that values that are more than 1.5 the IQR from the lower and upper quartiles are potential outliers. So let's calculate these the outlier test and find these cutoffs for our New England Patriot data. So our Q1 was 24, and if we did I calculate our IQR? I'm not sure. Our IQR was equal to 27 minus 24, which equals 3. So our lower cutoff will be 24 minus 3 times 1.5, which gives us 19.5. And our upper cutoff, 27, our Q3 plus 3 times 1.5 is equal to 31.5. And so now we are going to look at the data to see, does any of the data fall outside of those two cutoffs? None of the data is below the lower cutoff, 19.5. But we do have some data points that are above 31.5. In fact, we have a bunch. We have 4 data points that are above 31.5. And so we have a way to display this in a box plot. This is called a modified box plot. So in StatCrunch, we have the ability to create either a box plot or a modified box plot. The modified shows outliers using that method that we just tested. And what it does is it draws whiskers to the last data point before you've determined your outliers. So our last data points before the outliers was the age 31, and so it drew a whisker to 31. And then it displays your outliers as these dots to show you, yeah, this data is here, but it's so far away that we think they're possible outliers. One thing we want to be careful about is when we looked at the dot plot, there was actually 3 data points here, and so we're not seeing those 3 separate data points on this. So once you've identified potential outliers, you want to go back and look at them and see, why are they outliers? There's several reasons we might find an outlier. It actually might not be an outlier at all. So even though here below, if you look, this is a box plot and histogram of international math scores for 42 countries. The box plot, when they did the outlier test for a modified box plot, showed that one, South Africa, was a potential outlier. But if you look closer at the histogram over here on the right, there aren't any separations. There's no extreme. It's not separated from the bulk of the scores. So this really isn't an outlier that we need to be concerned about. It probably just barely didn't make the cutoff for the outlier test. The outlier may tell you something interesting about the data. The following shows the distribution of fuel economy in driving. The 2010 model sedans from Ford, Toyota, and GM in miles per gallon. So here are box plot and histogram again. And so we have 2 potential outliers. They show on both the box plot and the histogram. And why do we think that these are outliers, and what's an explanation? So maybe these ones are a hybrid, and that's why they're so much more fuel efficient. They must be different from the rest for some reason. And so you can look into seeing what's causing them to be so far different from the pack. And the third reason we might see an outlier could be the result of clerical error. So that might seem strange, but it's pretty easy to have a, like almost we could say a typo or someone putting something in wrong when they're entering data. And so here, if we're looking at ages of the New England Patriots and we happen to see this one way out here, we'd definitely be questioning this data point, because it seems highly unlikely we'd have someone in their 70s playing, or I'm sorry, in their late 60s playing football, and we might guess that someone typed it in wrong. Maybe that was supposed to be like a 29. And so definitely once some potential outliers have been identified, you always want to go back and look to see why they were, what they're telling us. So was there a mistake? Are they exceptionally different from the group for some other reason? Or maybe they're not actually really an outlier at all. And so just in quick summary, we have now looked at the box plot as a new graphical summary, very helpful when we're comparing 2 groups. Remember that the left-hand side of the rectangle is our Q1. The middle is our Q2 or median. The right-hand side is our Q3. Our whiskers go out to either in a regular box plot, they go out to your min or your max, or in a modified box plot, which is what this one is, we've calculated to see if there were potential outliers. Those ones will be dots. And then the whiskers extend to the last data point before the outlier. Okay, so that wraps up chapter 3.